Hello, I'm Aaron Park, and this is 7th grade, lesson 28. So in our first word problem, Christine is reselling books. She buys books for $N and then marks them up, which refers to marking up the price, by 5% each. The expression N plus 0.05N represents the new price of each book, which expression also represents this price. So just like the past couple of worksheets, once again we are simply simplifying, and in this case, we add the coefficients. We are able to do this because both of them have the same base, n. So we write that base out, the same variable n, and then we add 1, the invisible 1, plus 0.05 to get 1.05n, which is D. 2 is another problem that we're pretty familiar with by now. Which expression is equivalent to the sentence below? P is decreased by 6.5%. Decreased, which means it's going to be smaller. Or in other words, less than 100%, and 100% is equal to 1. So right away we can eliminate these two because their coefficients are both greater than 1 instead of less than 1. You can probably determine that this person or these choices are meant to trick you because you think that 100%, you just drop the percent and it stays like a very big number, but it's not true. A decimal is a percentage, not these whole numbers, these big ones. Now, P is decreased by 6.5%. This doesn't mean it's decreased to, it's decreased by. So, we need to subtract however much is being decreased from the total, which is 100%. And this gives us 0.935. This is how much we have left. But how much of what? Well, of course, it's P. So if we add all these, you'll see that the answer is A. Now, the dimensions of Martha's new furniture piece are W and H, kind of like a rectangle. The expression 2 times the quantity W plus H represents the perimeter of the furniture, which expression also represents this perimeter. Now, here we use the distributive property to distribute this 2 to the terms inside. Basically, 2 times W is 2W, and 2 times H is 2H. So, the answer is D. I'll let you do 4, 5, and 6 on your own because they're similar to ones we've already done. Let's look at 9. Alejandra bought T bottles of 1-liter apple juice and V bottles of 2-liter orange juice. The expression T plus 2V represents the total number of liters of juice, which expression also represents that number. This is similar to the one we just did, except we're working in reverse. We have a value, we have the T plus 2V, and now we want to turn it into something with a 2 in front. Equals 2 times what? Well, of course it's still going to be T plus V. We just need to determine the coefficients. This is called factoring out. When you factor a number out, you're basically dividing each one inside. So, what is T over 2? Well, of course it's half T, or 0.5T. And what's 2V divided by 2? Well, of course, it's just V. This gives us C as our answer. Now, this last page is introducing standard form, and all of these problems are written in scientific notation. Scientific notation is characterized by we have some sort of number times 10 to the power of something else. A whole number. N will be a whole number. So, why do we use this funky looking format? Well, it's because it helps us represent very large and very small numbers. Let's say we wanted to write 1,000,000. Well, I could write one with 6 zeros after it. That works. Or I could write 1 times 10 to the power of 6. These are the same. One is a lot faster to write. Now imagine if it was 1 billion, or 1 trillion, and so on. You can see why scientific notation is very useful. The same goes for very small numbers. For instance, this number right here is kind of a pain to write out, but you could also represent it as 2.7 times 10 to the negative, that's right, negative. And how many? Well, let's see. 1, 2, 3, 4, 5, 6, 7. The decimal point would move right 7 places, so the answer is 10 to the negative 7. Notice that the decimal point doesn't end up here, it ends up here. That's because in scientific notation, we want there to be one place in front of the decimal, and only one. Here there'd be 0, because it'd just be zeros here, 0.27. And if we move it another time, then there's 2 in front, which is not good. With that out of the way, let's write these numbers in standard form. So a quickie way to do it is write out the number 2.6, then move the decimal point right or left, depends on the sign of the exponent, however many times the exponent is, the power. If it's positive, the number is going to increase, right? So the decimal point moves right 3 times. 1, 2, 3. And we fill in the gaps with zeros. So 2.6 times 10 to the 3 is 2,600. You can repeat for all of these other numbers. Now if it's negative, we move the decimal point to the left. 1, 2, 3. So 6.0 times 10 to the negative 3, or 6.1, pardon, is 0.0061. That's all for today. See you next time.